So you are welcome to the second session under Unit 3, which is the synthesis of anthracene. At the end of the session, you should be able to describe the general method for the preparation of anthracene. You should be able to describe the synthesis of substituted anthracene using substituted benzene. And then, of course, lastly, you should be able to prepare substituted anthracene from a polynuclear compound. You know what polynuclear compound is. So on the synthesis of anthracene, there are four key synthesis approach that we'll be talking about in this session. First of all, we look at the general method for synthesizing anthracene. We are going to look at the Diels-Alder cycle addition reaction. We're going to look at the ELF synthesis as well, and then finally the synthesis of anthracene from benzyl chloride. So first of all, we'll talk about the general synthesis of anthracene, and this is just like the synthesis of naphthalene we talked about in the previous session. He said naphthalene can be synthesized through the Heterocyclic acylation. That's the same thing. So we have the phthalic anhydride that undergoes the Heterocyclic acylation with benzene to form this compound. So the ring closure after the Heterocyclic acylation leads to the formation of an anthraquinone. Now this anthraquinone can be reduced to our required anthracene, right? So basically this is the same approach that was used in the synthesis of naphthalene, and you can use this same approach, except that here it's not a succinic anhydride we are using, but we are using phthalic anhydride. Now this approach is used mostly in the synthesis of dyes. So there are cases where we try this anthraquinone, which is used in the synthesis as a precursor in the synthesis of variety of dyes can also be used. This approach can also be used in the synthesis of anthracene. So next is to talk about the Diels-Alder cycle addition reaction, which is also used in the synthesis of anthracene. So here we have our p-benzoquinone, which reacts with 2 moles of 1,3-butadiene. So it forms this 9,10 anthraquinone, which is then reacted with reducing agents to produce our anthracene. Okay, so next is the ELF synthesis of anthracene, and this ELF synthesis is a reaction that enables the synthesis of condensed aromatic systems. Now in this particular reaction, a polynuclear hydrocarbon is formed by pyrolysis of diaryl ketone containing methyl or methylene group auto to the carbonyl group. So this is more of an intermediate reactant that is being refluxed or condensed at high temperatures between 400 to 450 degrees Celsius to produce an anthracene. And the preparation of anthracene can also be done or synthesized through the use of a benzyl chloride. So in this case, these are 2 moles of benzyl chloride that are involved in this Heterocyclic reaction. So this is typically a Heterocyclic reaction. However, it's slightly different from the use of phthalic anhydride with benzene. Here, it's not a reaction between phthalic anhydride and benzene. However, this reaction is between 2 moles of benzyl chloride, and it produces the same 9,10 dihydroanthracene, which is then reduced to our preferred anthracene. Okay, so now we've looked at 4 different approaches used in the synthesis of anthracenes. Now realize that throughout all those processes, we ended up with a non-substituted anthraquinone, which is the product form. However, there are also ways of producing some mono-substituted, di-substituted, or in general some derivatives of anthracenes. So produces an anthraquinone, which is a monosubstituted anthraquinone. So the appropriate reducing agent being used will therefore lead to the production of our required monosubstituted anthracene. And then also there's other approaches. This is the synthesis of a polynuclear compound using two fused benzene rings through the same Federcraft reaction. This same process can go through the same mechanism of reaction as the first to produce a four-membered fused aromatic system. So please take note of these two approaches. Okay, so the last method to be discussed in synthesizing derivatives of anthracene will be the use of the Grignard reagents in introducing a substituent on another part of the ring. So in this particular scenario, the derivative is attached, or the substituent is attached to the middle ring through the using the intermediate O-benzoyl benzoic acid. Afterwards, then the ring closure also goes on using HF. Then our Grignard reagents can react with the intermediate to produce an alcohol derivative. Now, this alcohol derivative is then hydrolyzed, leaving our R group, the substituent we want to keep on the anthracene on the final product.